Hey everybody, we're going to do Surds today, but this is a GCSE Higher topic only. And yeah, there's an awful lot of easy jokes can be made about Surds because, of course, Surd rhymes with, yeah, which maths topic. If you don't like it, it's a very easy thing to make. Yeah, so some people really dislike Surds. I particularly like it because it's got many similarities with rules of algebra and things like that. And you know I like algebra. Loves algebra here. So if you like algebra, there's a good chance that you will also like this. So I'll tell you what we're going to do in today's lesson. I'm going to have to define what a rational and an irrational number is. Okay, we'll work out what a surd is, and we'll manipulate and simplify some surds. And afterwards, I'll show you some examples of exam questions or uses of exam questions to see if we can prepare you for what's going to come. Okay, so let's start off with defining what a rational number is. Well, a rational number is one that can be written as a fraction. So something like the number 7, for instance, can be written as 7 over 1. Uh, 20 is 20 over 1, etc. So any kind of whole number is going to be rational. But even something like 1.5, 1.5 is 3 over 2. Um, Even something like 0.33333333, etc., etc., is rational because it can be written as a third. Okay, so usually it'll be ones that you recognize. Okay, so an irrational number is one that isn't rational by reverse. That may seem like a bit of a vague explanation, but you'll see as we go through what kind of irrational numbers look like. So, what about the number 8? Is it rational or irrational? What about pi? Number 3 is 0.75, and number 4 is the square root of 2. You can pause, and now unpause, and I give you the answers. Well, 8 is rational because you can write it as 8 over 1. And like I said, any whole number is going to be rational because you can always write that number over 1. What about pi? It's irrational because it's 3.1421592, etc., etc., etc. And it's an infinite decimal and will go on forever. In fact, one of the reasons that I think it's called pi is because it is an irrational number, and they wanted to make some more sense because it's more commonly used than most irrational numbers. So they give it the Greek letter pi to signify its importance. What about 0.75? Well, it's rational because you can write it as 3 quarters. And as you can see, it's not an infinite decimal. It has a very distinct stop to it. So it can be usually a good clue as to what an irrational or rational number is. What about the square root of 2? Well, it's irrational because it's 1.14213, etc., etc. And this makes the basis of our lessons because a square root of 2 is a surd. Surd, I'm not actually sure where the word comes from, but if you say the word squared really fancy quickly and in a Northern Irish accent, you will get squared, surd, right? So it's usually a square. Well, it's not usually. It is a square root number that's irrational. So it can't be reduced to a whole number. So it's not one of the common ones that you already know. For example, root 2 is a surd because it's 1.14, etc., etc. Square root of 5 is also a surd because it doesn't come round down to a square root number. And last but not least, square root of 81 looks like a surd, but isn't really, because the square root of 81 is actually 9. Are you completely confused yet? Basically, any square root number is going to be a surd unless it becomes a whole number when you put it in the calculator. And some of those you already know. Square root of 1, 4, 9, 16, 25, 36, 49, 64, etc., etc. Let's look at some questions. Or let's look at some of these. So square root of 2 is a surd, and there's what it looks like. Square root of 8 is a surd because it's going to go on forever and ever and ever and doesn't come down rightly. What do you think will happen when you multiply these two numbers together? So if we multiply square root of 2 and square root of 8, what do you think is going to happen? Now you can pop it in your calculator and see what happens. But I'm going to give you rule 1 of surds. And that's the square root of a multiplied by the square root of b is the same as the square root of a times b. Let's put that into play. The square root of 2 times the square root of 8 is the square root of 16. So square root of a multiplied by square root of b is the square root of a times b. So it's the square root of 2 times 8, which is 16. And the square root of 16 is then 4. Okay, so if you'd put it in the calculator, square root of 2, square root of 8, you'd have got 4 as your answer. But the reason is because root 2 times root 8 is root 16. You multiply the two numbers under the square root together, and then you can simplify square root of 16 down to the 4, like we had there. What about 2 times 18? Well, if you put it in the calculator, you will get 6, but the reason you get 6 is because the square root of 2 times the square root of 18 is the square root of 36, and the square root of 36 is 6. What about the square root of 4 times 9? Well, square root of 4 is 2, square root of 9 is 3. That gives you 6, but it's also the square root of 4 times 9, which is the square root of 36, which is also 6. Square root of 3 times square root of 5 will give you root 15, because the square root of a times the square root of b, square root of a times b, which is 3 5s, which is 15. Did you get the idea? Okay, give yourself 3 minutes, hit the stopwatch, using that rule, and you're not allowed to use your calculator. Go. I'm not going to sit here for 3 minutes. You're going to pause the video, and I'm going to show you the answers right now to see how you went. And you should have gotten those answers. So the square root of 3 times square root of 12 is the square root of 36, which simplifies down to 6. 3 4s is the square root of 12, doesn't go down anymore. 2 5s are 10, doesn't go down anymore. Square root of 5 times the square root of 5 is the square root of 25, which square root of 25 is 5. 9 6s are 54, doesn't simplify down. 5 20s is the square root of 100, which obviously you know the square root of 100 is 10. Square root of 3 times the square root of 27 is the square root of 81, simplifies down to 9. And 2 times 3 is 6, and 6 times 6 is 36. The square root of 36 is 6. I hope you got on all right with those, because we're going to move on. If you didn't, you can rewind back a little bit and see if that makes some sense. What about rule 2? The square root of a divided by the square root of b is equal to the square root of a divided by b. Okay, very similar rule to the last one. We're going to combine those two rules together. So the square root of 8 divided by the square root of 2, if you put it into your calculator, you will get 2. But the reason is because you get the square root of 8 divided by 2, which is the square root of 4, which is then 2. 27 divided by 3 gives you 9, and the square root of 9 is then 3. Square root of 36 divided by the square root of 9 is the square root of 6 divided by 3, which is 2. But 36 divided by 9 also gives you the square root of 4, which is also 2. And 15 divided by 5 is going to be the square root of 3. Okay? That's your rule. It's a bit like a bit like algebra in many ways. Then you're going to cancel down, etc. But square root of a divided by the square root of b is the square root of a divided by b. Altogether. Very similar to the last one. Here are some for you to try. 3 minutes. Pause the video. And now that you've unpaused it, I'll show you the answers. Remember, you're not allowed to use your calculator for those. You would have got 2, because 12 divided by 3 is the square root of 4. 4 is 2. 44 divided by 4 is 11. Alright. The 100 divided by 4 would give you 25, and the square root of 25 would give you 5. Square root of 25 divided by 5 is the square root of 5. 81 divided by 9 is the square root of 9 again, which is 3. 75 divided by 25 is the square root of 3. Square root of 28 divided by the square root of 7 is the square root of 4, which is 2. And then you do your brackets first. So 2 times 9 is 18. The square root of 18 divided by the square root of 3 is the square root of 6. And I hope you got on all right with those. Simplify the following surds. So these ones are going in reverse. So I'm going to give you the surd and then see if you can break them up into smaller bits. And basically what you're looking for in these things is, can any square numbers that I know of multiply into these numbers? So into 12, for instance. So there's the square roots that go. Square root of 4 is 2, 3, 4, 5, 6, 7, 10, etc. But there are others. You know, obviously square root of 81, square root of 64, etc. So square root of 12 is square root of 4 multiplied by the square root of 3, and we know the square root of 4 is 2, so we'd usually just write that as 2 root 3. Okay, and a bit like when we're doing algebra, when it was 2x, etc., we don't put the multiplied sign between, but just stick the two of them together, and that signifies that they're multiplied together. but like we discussed previously. Square root of 32 is the square root of 16 times the square root of 2. Square root of 16 is 4, so we get 4 root 2. What about 72? 72 is the square root of 36 multiplied by the square root of 2. Square root of 36 is 6, so you get 6 root 2. Square root of 80, as I pause, is 16 fives. So we would get 4 root 5. Square root of 44 is 4 11s. So it's 2 root 11. Square root of 700 is 100 times 7. Square root of 100 is 10. So you get 10 root 7. And I'm going to leave the square root of 147 with you. But you should be able to work out what it is. And I'll give you the answer in class later on next week. Alright, just to see whether you really have sorted out. You can just come in, and as you're walking in the door, just give me that answer. And then I know you get it. Okay? Good stuff. What about this? So expand and simplify the following surds. And as you see, these ones have brackets in them. But treat your surd like you would your algebra, like the x term or the y term or the unknown term. Square root of 5 times upon 3 minus the square root of 5. If you want, write them in as an x at the moment. So if you had x times 3, you would just get 3x. And then you would do root 5 times minus square root of 5. So x times minus x would give you minus x squared. Now when I do this, the 3 root 5 is quite simple. But the minus the square root of 5 times the square root of 5, well, that's minus the square root of 25, which we can simplify down to being just 5. Okay. The next one is very much a quadratic equation. Okay, so we use our FOIL method if you want. So we would do our first two. 2 times 6 is 12. Then with plus root 3 times minus root 3, it's going to be minus root 3 times root 3. Then you're going to have your inner 2, which is 6 root 3, plus 6 root 3, and then your outer 2, which is going to be minus 2 root 3. And if I put those all together, I'm going to have 2 times 6 is 12. Inner 2 is minus root 3, then plus 6 root 3, and minus 2 root 3. And you can work through those yourself. If I pull those all together, the root 3 is going to be the square root of 9, which is 3. So I'm going to have 12 minus 3, plus 6 root 3, minus 2 root 3. The 12 minus 3 will give me 9. And much like my monkeys, one that I use all the time, what's 6 monkeys plus 2 monkeys? It's 8 monkeys. 6 monkeys take away 2 monkeys is 4 monkeys. With 6 root 3 minus 2 root 3 is 4 root 3. Okay, so you can, those square root numbers are very like you would treat your x. And if you see them in this kind of problem, then you just, if you want to rewrite the problem with an x or a y or an a or a b or a t, u, v, whatever, stick them in, see what you would do, and then you can put your square root numbers back in. Remember, 1 minus square root of 7 all squared means 1 minus root 7 multiplied by itself. And we go through the same process, the two numbers multiplied together, last two, inner, outer. You should get 1 times 1 give you 1. Then minus root 7, plus root 7 because there's a minus minus. Then a minus 1 root 7 or minus root 7. And then minus another root 7, like that. The root 7 times root 7 is root 49. Square root of 49 is 7, so you have 1 plus 7. And then you have minus root 7. Combine our terms together. 1 plus 7 gives me 8. And minus root 7 gives me minus 2 root 7. Silence. Okay, here's some for you to try. I've left you a couple of extension questions there, so a bit harder to do. And I will go through those in class when we start off to see if people have been following along. The extension one, write down 2 surds that when multiplied give a rational number. You should think back to what we did earlier on and see what happens there. And write down 2 surds that when multiplied do not give a rational number. Should be an awful lot easier. Write 3 plus root 2 minus 1 upon 1 minus root 8 in the form a plus b root c, where a, b, and c are integers. Again, those are extension parts. They are really to see if you've truly been able to grasp what we did before and apply it, more importantly. Let's see. Okay. Rationalizing surds. So this is the topic. Multiply top and bottom of the square root you're trying to remove. Now, If I was given the number 3 over root 5, that does not give a rational number. One, because that isn't, I can't write that as a fraction, right? That is not a fractional number because the square root in the bottom is going to be an infinite decimal, right? So what we generally do is we try and get the square root thing on the top, right? Because the top number can be a decimal in a rational number, but the bottom one can't, because remember when we were doing even divide by decimals, we can't divide by a decimal. That's where we're going. So we're going to rationalize a third. So you multiply top and bottom by square root of 5, and the reason you can do this is because root 5 divided by root 5 is just 1, so it's like multiplying by 1. It's a bit like multiplying a million divided by a million. A million divided by a million is just 1. Anytime those things together, and as long as we're not changing the number beforehand, we're just going ahead and manoeuvring about what way it looks. So we multiply 3 times root 5, and we get 3 root 5. We get our square root of 5 times the square root of 5 is the square root of 25, which gives us 5. So we end up with 3 root 5 over 5. I'll go through that again. When we see a third in the bottom, it'll tell you to rationalize a third. You multiply top and bottom by root 5. 3 over root 5 times root 5 over root 5. The reason you can do it is because that would cancel down to give you 1. You can put in your calculator to check if you really want to, but it will give you 1. And then you do 3 times root 5 to give 3 root 5. Then our root 5 times root 5, remember, gives us a square root of 25, which then gives you 5. So we'd end up with 3 root 5 over 5. If we 3 over 2 root 7, we don't have to multiply top and bottom by 2 root 7. We just multiply top and bottom by the root 7. If I do those, I get 3 root 7 over 2 times root 7 by root 7 is root 49. Root 49 is 7, so we get 3 over 2 times 7, which is 3 root 7 over 14. Same thing again. 10 over 7 root 5. Multiply top and bottom by the square root, or the third, and we'll end up with 10 root 5 in the top, and then the root 5 times root 5 just becomes square root of 25, which is 5, so it's 7 times 5 in the bottom. We'd end up with 10 root 5 over 35, but 10 over 35 simplifies down, and it will simplify down to 2 over 7. So we'll end up with 2 root 5 over 7. And if you want, I'll go through that in class to show you how that fraction simplifies down, but that's what we do. Let's try some of these. 7 over root 3, 4 over root 6, 14 over 3 root 10, 4 over 9 root 2, 2 root 5, divided by 7 root 3, 6 root 3 divided by 11 root 2. I expect some of those later ones will cause you some problems, but your answers are as follows. And again, I'll go through them in class when you're in. First thing I'll start with that day. Okay. What about adding surds? Can we do it? Well, I'm going to start off by showing you that if you try and use the rules that we used beforehand for multiplying, so that plus that would be the same as the square root of that plus that would give you the square root of 25, which would then give you 5, right? Except the square root of 9 is 3, we know, and the square root of 16 is 4. If I add 3 plus 4, that gives us 7. So that rule cannot apply, right? The one that we used, or that seems to work for multiplying surds, doesn't work for adding them. So the general rule is that there is no general rule, and there isn't a rule for adding or subtracting surds, and you just have to treat them as nearly an x and a y, so they're two different terms. You could add them like you would in algebra, so if it's root 7 plus root 7, that would be 2 root 7, but like we discovered before. Treat it as an x, as long as it's the same surd, and you can add and subtract them to your heart's content. So with 2 root 11s here, then we're going to do 15 minus 8 gives us 7 root 11. Right, an exam question. Expand that, just like we've done beforehand, but write your answer in the form a plus b root 3. So 5 minus root 3 all squared is those two brackets multiplied by themselves. And we'd use our FOIL method. So 5 times 5 would give me 25. Then we've minus root 3 times 5 there. And then minus the outer, which is minus 5 times root 3, plus root 3 times root 3, which is two last ones. If I group those together, I have 5 root 3 minus 5 root 3 plus square root of 9. With 2 minus 5 root 3's, that will give us minus 10 root 3 there. And the square root of 9 is 3, so if 25 plus 3 is 28. I'm going to have 28 minus 10 root 3, and that is in the form a plus b root 3 because the a is 28 and the b is 10. And that's a very typical exam question. Now, those are your rules. Let's do another couple of exam questions. Find the area of the triangle below. So area of a rectangle. Area of a rectangle is length times breadth. You take your 2 root 3, multiply by 1 plus root 27. You multiply through there. You get 2 root 3 times 1, which gives you 2 root 3. And 2 root 3 times root 27. 3 27s using that rule, rule 1. And you get the square root of 81. Square root of 81 is 9. And 2 times 9 is 18. So our answer becomes 2 root 3 plus 18 because we can't combine those because we need the same square root underneath both. That would be centimetres squared. What about the missing length? And as I say, this is what would say is a grade A star question. Work out the missing length using Pythagoras' theorem. Okay, we know this Pythagoras' theorem is a squared plus b squared equals c squared. So in this case, we've got square root of 8 squared plus the square root of 10 squared equals x squared. Square root of 8 squared is just going to be 8, or root 8 times 8 root 8, which is going to be 8. Same with square root of 10. Multiply those two together, it's just going to be 10. X squared is going to equal the square root of 64 plus square root of 100, which is 18. And then x is going to be the square root of 18, which you can then simplify down to square root of 2 multiplied by the square root of 9. If you wanted to observe, that would be 3 root 2, or you could just turn it straight into the decimal and do 4.2 centimetres. That's the one decimal place. Remember, to simplify surds, you turn them, simplifying surds like something like this, adding these two together. The only way you can do it is to try and get a common factor, so to speak, of a root 3. And then you could take the common factor of the root 3 out. So root 12, root 27, 12 and 27 both have a common factor of 3. You could then do root 4 times root 3, root 7, root 3. Square root of 4 becomes 2, square root of 9 becomes 3, and you'll be able to combine them together. You can have to spot the square numbers that are there. It's quite tough, but usually if you get it in an exam question, there is some rhyme or reason to it. There would be something there to see. Remember to use FOIL, the table method, for doing those kind of ones, and then you'll get those together. And rationalising the denominator, we multiply top and bottom by the square root thing in the bottom. Now there is one type left for rationalising the denominator. And yeah, I'm going to show it in class because I'm going to set it as homework for the following week. We're going to do it in class and set it, and then I will addendum the video that we have here. I will do a slightly separate video. Don't want to throw too much at you because surds can be quite a tricky topic. We've had some examples there to do while you're doing along. Good luck, and I'll see you in class on Tuesday. Take care. Bye.